I'm Anil Kumar, and here is a very interesting question on rates of change. An object moves in a straight line with its position at time t seconds is given by s of t equals to 8t minus t squared, where s is measured in meters. Find the velocity when t equals to 0, t equals to 4, and t equals to 6. So whenever you need to find velocity when displacement is given to you at different times, it is important to find a general expression, right? As you know, what is velocity? Velocity is rate of change of displacement, right? So it is rate of change of displacement. That is what velocity is. Velocity is instantaneous rate of change, and so we are looking for limit where delta t is approaches 0, right? We could also write this expression as limit h approaches 0, where we could now write here as s of t plus h minus s of t divided by h. T plus h minus t will give us h. So that is the difference quotient formula, which can also be utilized to find a general expression. So let us find the general expression for velocity, which is rate of change of displacement or position vector. So s of t plus h is replace t with t plus h. So we get limit h approaches 0. T plus h means 8 times t plus h minus t plus h whole square, that is s of t plus h, minus s of t, that is 8t minus t square, and everything is divided by h. Now let us expand the numerator and simplify. 8 times t is 8t plus 8h minus, that is t square plus 2th plus h square, and then we have minus 8t plus t square, everything divided by h. At this stage, what you will notice is that all the terms with h remain, right? So let us see what cancels out. So minus t square plus t square is 0, correct? Minus 8t plus 8t is 0. So what we are left with is 8h minus 2th minus h square divided by h. Now we can take h common, so we get limit h approaches 0. So if I take h common, I am left with 8 minus 2t, right, minus h over h. So h and h cancel, so we can write this as limit h approaches 0. So we are left with 8 minus 2t minus h. Now we can substitute h equals to 0, so we get the limit as 8 minus 2t. Now this is the general expression which I am talking about. So once you calculate the general expression, that is the rate of change of position with respect to time is 8 minus 2t, right? So let me write down this general expression here. So we have velocity as equals to 8 minus 2t. Now we can find velocity for different time intervals. So when t is equals to 0, what is velocity? So we can substitute t equals to 0 here, right? So in a way, you can write like this also. We can say velocity at t equals to 0 is, substitute t equals to 0 here, 8 minus 2 times 0, which is 8. And of course, the units will be meters per second. Similarly, we can find the velocity at 4 and 6. So we say velocity at t equals to 4 will be, we'll substitute 4 here, 8 minus 2 times 4, which is 0. 8 minus 0 is 0 meters per second, right? Now the third one is calculating velocity at 6. So let us say velocity v at t equals to 6 equals to 8 minus 2 times 6. So 2 times 6 is 12. So we get minus 4 meters per second. So these are the three answers for the respective times t equals to 0, 4, and 6. The velocities are 8, 0, and minus 4, right? So for this particular function, 8t minus 2t square minus t square, it is interesting to note that the velocity actually is changing, and it is 8 initially, and then it becomes 0 and minus 4. It will be interesting to graph these two functions on the same graph. So let that be an exercise for you. So you know this function minus t square means downside. We have two x-intercepts, one at 0. The other one will be at, so if I take 2 common, right, let me rewrite this function and sketch it. So we have, let me write here, s of t equals to, if I take 8 common, I got 8 minus t. So I have two zeros here. So based on that, I'm just sketching kind of a rough sketch here. So we have two zeros. One is at 0, the other one is at 8. And t is greater than 0, of course. So we could say the function is kind of like this, right? So that is how the function is going to be. And as you can see, right here, which is the turning point, the velocity is going to be 0. And this turning point happens to be right in the center, right? So this turning point is at 4. So it's 0, 8, and 4. And as you can see here, the velocity here is 0, and thereafter it is negative. So the tangent is negative, correct? So let me push this a bit here. So what you find really is that the velocity initially is 8 meters per second, so it is kind of here, and then it becomes 0 here, and then it's negative at t equals to 6, correct? So it's kind of a straight line. You can draw it like this, kind of, right? So that is the velocity for the displacement function, right? So velocity is represented by this straight line, correct? And so this value is 8 for us, right? This is 8, and this value is 0, and somewhere for 6 it will be minus 4. So at times we may be required to sketch the displacement or position graph and the velocity graph on the same scale. So this will kind of help you in answering such questions. I hope with this you understand how important it is to find a general expression and then find velocity at different intervals of time. This is an excellent example. Go through it once again and then move forward. Thank you and all the best.